Hello, everybody. My name is Aris. Together with my fellow student Nikos, we have chosen to make a project for our big data course for the Master in Science program on data science in the University of Nicosia. Our subject that we have chosen is the sentiment analysis on streaming COVID-19 tweets. As we're still enduring the pandemic, we thought that trying to analyze data relative to it would be something interesting and hopefully fun. COVID-19 has raised various reactions and arguments regarding several aspects of the pandemic, such as the vaccinations or even the validity of the virus itself. Nowadays, social media platforms are a basic way of expressing opinions and sentiments towards a subject, especially under the pandemic, where physical contact has been minimized. This creates a huge and constant flow of relevant data that need to be analyzed. For instance, depending on the news feed, the audience's attitude and sentiments may shift. This results into a need of analyzing this attitude fluctuation. Such an analysis is useful in many ways. For instance, governments might be interested in the opinions, attitudes, or sentiments of the public after the announcement of a relevant policy.
So, hello everyone, my name is Nick, and together with Aris, for tackling the subject that Aris describes us, we formed a hypothesis in order to examine the general public consensus towards the pandemic and related news in United Kingdom. For doing so, we decided to analyze tweets, streaming tweets. So we did that in a live setting, let's say in a real-time setting. For this reason, we used Tweepy, and because we had to tackle some big data problems, like the volume of data and the velocity of data, we used also the Spark, the Apache Spark. However, we faced a great challenge because we chose to use Spark on Windows. And this was something very challenging, and it took us many hours to find solutions to many problems. So in the description below the video, you will find an extensive guide on how to use PySpark on Windows. I'd advise you not to do so. You can use PySpark on Linux, or you can do such a work on a cloud setting. But if you want to proceed with Windows, you will find the guide in the description. So, Aris.
Yes, one of the biggest challenges that we had to face was actually deploying Spark on our local machines. Personally, I didn't even manage to deploy it on my Windows computer, so I had to set up a new environment with Linux, with Ubuntu, which, by the way, was really easy, and it just deployed at once. No extra effort needed for this one. So, in regards to our solution, the first step that we needed to do was to apply to get access to the Twitter API. The Twitter API gives researchers like us, in this case, the opportunity to have access to the raw data provided by Twitter. There are some limitations, of course, but this can be found easily by anyone that is interested. So what we did was we set up, we used the Tweepy library on Python in order to set up a socket which would establish connection between the Twitter API and our local machines. Tweepy helped us receive the stream of tweets directly, like Nikos described earlier, in real time. And as a second step, we connected this that flow, that data stream, to PySpark in order to do sentiment analysis and get some useful insights from the tweets that were constantly coming. In terms of the big data challenges that we had to face, Nikos mentioned the volume and the velocity of the data. To give you an idea of the amount of data that we received, we received approximately 4,000 tweets per minute by using the keyword COVID, and that was just in the UK. I don't know if there would be more if we use the broader, let's say, area, but that's a lot of tweets. That's a lot of data. We are talking about hundreds of thousands of data in just a few minutes. Regarding the Spark, the Apache Spark solution, like Nikos mentioned earlier, we did it locally in our computers. What Spark did for us, we used it through PySpark, a library for Python, was to receive the data, to receive the tweets, do the sentiment analysis, and then produce for us the sentiment in terms of polarity and subjectivity. Polarity and subjectivity, the two main things that we analyzed. Polarity we can see if a tweet is negative, neutral, or positive. And in terms of subjectivity, this is a little bit more subjective because there are no strict guidelines as of which is the indication that we can consider subjective or objective. For our purposes, we decided to create 7 different indices, beginning from highly subjective, highly objective,
partially objective.
Partially objective, yes, thank you, Nikos. Neutral, and partially subjective, subjective, and highly subjective. The results that we received for the amount of time that we receive tweets, let's say, because it's not that easy to keep it to keep the stream coming for hours. So we used, if I'm not mistaken, around 30,000 tweets, and the results 40,000 tweets. Okay, thank you. After removing the duplicates, because there are retweets in those 40,000 tweets, we were left with around 29,000 tweets. From these, we received the following data. We have, in terms of polarity, 9,000 of those were neutral, 7,000 of those tweets were positive, and about 4,000 of these were negative. And when we're talking about the subjectivity for those tweets, the majority, or let's say around 9,000 of those tweets were highly objective. Neutral was the second most favorable, let's say, label. We got 3,500 neutral tweets, and then the rest had declining numbers. So yeah, Nick, you may proceed.
We also did something else. We found a dataset which contains tweets from a competition, and we decided to train a machine learning algorithm in order to be able to detect which of those tweets that we gathered contain real news about COVID and fake news. So we trained a model. After experimenting, we found the best model for our purpose. And as you can see here, the majority of the tweets, the 67% of the tweets, contain fake news about COVID. And the 33% contain real news about the pandemic. However, even though our trained model had very good scores, for example, after the cross-validation, we had 95% accuracy, and on the validation dataset, we had 92% accuracy. Those results, it is important to be taken with a pinch of salt, because the dataset that we used in order to train our model is rather old. It's from December of 2020. And in these cases, where the pandemic is ongoing, the data have to be renewed all the time in order to have more good results about your labeling of the news. And this is, Either way, those algorithms, and if you see on the social media, they always need the human interaction, because what they do is they flag a post or a piece of news, and then a human reads the post and says if it is real or fake. In the future, with some self-learning algorithms, it might be easier, or the human interaction might be less needed. But at this point, this is where we are. So again, I have to say that the prediction about the fake and real news has to be taken with a pinch of salt.
It's more of an indication, let's say.
Of an indication, yes. We don't know if this is accurate and how accurate it is.
Another thing that we did in regards to the streaming data was we created a live dashboard. This dashboard represents in real time the hashtags, the most popular hashtags that are being mentioned on the tweets that we have been receiving. If there are no hashtags, then no hashtag is being counted. But for those tweets that do have hashtags in them, this live dashboard, what it does, it gets the count of all those hashtags, and then with a refresh rate of around a few minutes, it updates and constantly gives the top 10 in terms of popularity for the hashtag count.
It creates batches, batch data again through Spark with a, if I remember correctly, with a 5-second window. Yes, with a 5-second window.
So it's a short window,
Yes.
I believe that in terms of our solution, I believe that was all.
Yes.
Okay. So what we have discussed with Nikos is that it was a big challenge for us, mainly because of a lot of technical hinders that we faced along the way. It was a really interesting project, and really something that we want to expand in the near future, like Nikos mentioned, with another type of algorithm in order to make a better model for how's it called? Help me, Nikos.
Prediction of fake and real.
Prediction of fake and real news, and yeah, that would be all from us.
And for me, I have to say that it was one of the most challenging projects that I have done. Only because of the Windows, only for this reason.
I remind everyone, do not try this on your Windows machine. You may get.
But if you could,
you may get
if
very
you would like
frustrated.
to do that, follow the guide below in the description, and it might work.
Otherwise, just get a Linux machine or set up a Linux virtual machine on your Windows computer and do that over there. It will be a lot more frustration-free process for all of you.
Or use the cloud.
Or use the cloud. Make a cloud deployment. So if you have any questions, you can find our contact details on the description of the video. There is also a GitHub repository that we made with all the code and all the scripts that we used in order to make this happen. Of course, the actual files that we received are not being made public. Neither are the Twitter API credentials. You need to use your own. For any questions or anything that has to do that is related with the topic, feel free to contact both me and Nikos. We would be happy to have a conversation and discuss about the matter. Have a nice one.
Yes.
Stay safe.
Bye-bye. Thank you.